Reaction set number 2 and 3 will cover 4 different types of synthesis reactions. In synthesis reactions, you'll see a single product form. It could form from 2 elements, 2 compounds, but you have one single product that forms. The first type is the one that we've done before. A metal and a nonmetal form a binary salt. Binary means there's only 2 elements involved. And so, just like we've done before, you'll take lithium and nitrogen. Nitrogen happens to be diatomic, but when you go to form the compound, you're going to look at the charges of the 2 elements. So you would have lithium 3 nitrate, and then go back and balance the equation. So those are the simple synthesis reactions. In this reaction, we don't really care about the states of the elements, whether it's a vapor or a solid metal. We just want to know what elements are involved. And so in this case, we have sodium. Remember, elements by themselves are not charged. We have iodine, which is diatomic. And then we're going to use the charges of the 2 elements to make the formula. So we have NaI, and then we'll balance the equation. In this reaction, magnesium metal, so solid magnesium, no charge, single element, reacts with chlorine gas. And again, use the charges. So you would have 2 chlorines in the compound. And it happens to already balance. In this reaction, lithium metal, so we have neutral lithium, is burned in air. Now, in the combustion reactions, we always said burned in oxygen. When you have air, is actually a mixture of gases, inert gases like nitrogen and other things. But if you're going to, somebody's actually going to burn in air, it's actually reacting with the oxygen. So if a reaction ever says burned in air, they mean burned in oxygen. And so again, use the charges and put the compound together. And then balance. In this reaction, excess chlorine gas, which will mean something later on to us that it's excess, is passed over iron filings, so Fe. And now we don't have a charge for this iron. Remember from the summer work, iron can be +2 or +3, and we said other than silver, there's always +1. If you need to figure out a transition metal charge, the majority of them have a +2 ion charge. They may have a different other charge as well, but you're usually safe going with +2. And so in this case, the reaction would already be balanced. You could have used iron +3, in which case your product would have been FeCl3, and then you would have to balance it differently. But either one of those products would be correct as long as you balance the reaction. But you're always safe to go with a +2 charge on a transition metal, except for silver, which is only ever +1. The second type of synthesis reaction where you're going to form one compound is a metal oxide plus water. So a metal oxide is any positive ion combined with oxygen. Remember, the metals are on the left side of the periodic table. The alkali metals, the alkaline earth metals, the transition metals. So a metal oxide might be Na2O, it might be calcium oxide, it might be a copper oxide. Anything with a metal and oxygen plus water will be this type of reaction. And the product that forms when you have the metal oxide and water, in this case, will always be a base. A base, if you remember from first year chemistry, is anything that has hydroxide in it. So you might form sodium oxide, you might form calcium oxide, or you might form copper oxide. So in the first example, solid sodium oxide is added to water, and so you have some sodium ions. You have an oxygen from the oxide, you've got 2 hydrogens and an oxygen from the water. So you can see how hydroxides could be formed. And so this may not balance at first, but it will in the end. But what we're basically going to do is put sodium +1 with hydroxide -1 and make the base. So it has to be the positive ion with hydroxide. Now it doesn't balance right away, and so we'll go back and balance the reaction. In the next example, solid magnesium oxide, MgO, is added to water. So in this case, your ion, your metal ion, is Mg+2. So for your product, you'll put Mg+2 with hydroxide to make the base. And so you'll want 2 hydroxides to cancel the charges. And then if you needed to, you would go back and balance. This one happens to balance on its own. Solid barium oxide is added to distilled water. So your ion is barium plus 2, your metal ion, and you'll put it with hydroxide minus 1. And so your formula is barium hydroxide, and this one happens to balance on its own also. Solid lithium oxide is added to water. So the ion is Li plus 1 and hydroxide minus 1. So the formula, the base is LiOH, and then you would balance. In this reaction, hot water, and we don't really care about the temperature at this point, is added to strontium oxide, strontium's plus 2, and to form the base. So you would have strontium and 2 hydroxides, and happens to already balance. So when you look at these first two types of synthesis reactions, the first one is an element plus an element, neutral elements, maybe a diatomic like O2, going together to form an ionic compound, a binary compound, a 2-element compound that you put together with the charges. So that's the first type of simple synthesis. The second type is the metal oxide. Lithiums are metal. With the covalent compound, water. This cannot be a double replacement reaction because water is covalent. It's not made up of ions. Your only choice is to form a base. So you take your metal ion like lithium, put it together in the compound with hydroxide, and you have your base formula. And there'll be 2 more types of synthesis reactions that we'll do on set 3.